this is something similar to the one which we solved during tutorial 2. So but we may use some equations for the to solve this problem. So what we have here, the mixture of 50 mole percent benzene, 50% toluene. So feed x of something given 0.5. Benzene is the more volatile component here, is subjected to flash distillation at a pressure of 1 atmosphere. So P is given. So incoming liquid is heated to temperature that will cause a 40% of the feed to the 40% of the feed to flash. So this is means feed to vaporize. So the fractional vaporization F is equal to 0.4. So what is the composition of the vapor and the liquid leaving the flash chamber? So we have to know what's the temperature in the flash chamber, and what is the required feed temperature as well. See, we also don't know what's the feed temperature. So this is something easy to answer if we have the TXY diagram and the XY diagram. So how to determine the feed temperature? So we know that the feed contains 50% benzene and 50% toluene. So if we have the TXY diagram, so just draw a line. So that liquid or that fluid mixture should boil at this temperature, which is equal to 92 degrees centigrade. So feed temperature is 92 degrees centigrade. So this is a graphical method. Feed temperature is 92 degrees centigrade, and then we know that the fractional vaporization is 0.4. So we have to use the same equation which we derived just now. So y is equal to this x of by f minus this whole equation, x of by f minus 1 minus f by f into x. This is something we have here. So what is this? So either you can calculate the slope, and from there you can calculate x and y. So that's one way to do it. So if you substitute the value of so f is equal to 0.4, and then if you take the slope, so you may need a txy, you may need xy data as well to solve that problem. So from x and y, so we know that feed is the mole fraction of the more volatile component in the feed is 0.5. So the equation of straight line should cut at this point 0.5, 0.5, and then draw a line whose slope is equal to 1 minus 0.4 by 0.4 minus sign here, and from here you can get x and y. So this is one method. This is the something that we know how to do it, but here we have some other information that we can use instead of using that method. What we have here, sometime I may give something like this. So assume the temperature in the flash is 95 degrees centigrade, and the relative volatility at this temperature is given by 2.45, and finally check your results using the boiling point diagram given below. So I'm just throwing out the different methods to solve this type of problem, because in the exam you will never know what type of data you are going to get. So it's better you know all the methods to solve the problem. So if I give something like this, assume the temperature in the flash is 95 degrees centigrade, then the problem is already solved. So if the flash temperature in the flash drum is 95 degree centigrade, so that should be the exit temperature of the vapor and the liquid side. So then we know the corresponding composition and x if we know the temperature. So let's say if it's if the flash column is maintained at 95 degrees centigrade, then the expected mole fraction of A in the vapor side should be equal to, so X should be equal to, draw some line until this graph, sorry, until this line cuts the x-axis, sorry, they call it abscissa, so it's approximately um, 0.4, x is equal to 0.4, and the corresponding y should be equal to 0.61. So we already solved the problem because we know the temperature of the flash drum. So this is second way to solve the problem. So provided we have this information, the temperature in the flash. So but you cannot assume in the final exam like, oh, assume the temperature in the flash is 95 degrees centigrade. You should read the problem, you know? And then now let's use other method. So I gave something called the relative volatility at this temperature is 2.45, you know? So let's say, or I may give the flash column is maintained at some particular temperature, and at that temperature the relative volatility is given by 2.45. Then how do you solve it? So we know some equation that we already derived. So what we derived, alpha is equal to y by x, 1 minus x divided by 1 minus y. So now we have alpha is what, alpha is 2.45. So let's write a general equation which is something like x is equal to, and then all the other quantities goes to the right hand side. Yeah, so let's write like that. So alpha x minus alpha xy equal to y minus xy. So let's take x and what is this, alpha x minus, this is not correct, minus alpha y minus alpha xy. Oh no, sorry, that's correct. Alpha x minus alpha xy, that should be equal to y minus x minus y. So what we do here, equal to, so let's write minus xy equal to, so plus xy. So how do you write this? I'm trying to make the equation bit simpler. Now let me give a try. For minus alpha y plus y is equal to y, so x is equal to y by alpha minus alpha y. I think I'm complicating the things here, that's what I feel. No, I think I'm complicating the things. I will make it a bit more simpler. So let's delete this whole thing here. We already have a mass balance equation, so we can use that equation to solve this problem. So let me try. So we have that, let's go up. So we have the equation of straight line, if you remember, so which is here, y is equal to x of minus this whole function is here, yeah? Into x. Okay, and then we can rewrite this bit more simpler. What I'm going to do is I'm going to multiply both sides by f, so that and then I'm going to take x on one side, or we can do something, So what we have here, we have alpha equal to 2 point, what's this number? We have alpha is equal to 2.45. So we can eliminate y or x from by using this equation. So let's try to do that. So how do you do that? So I'm going to rewrite this equation. So how do you write? So alpha x minus alpha xy equal to y minus xy. I'm going to take all the y on the one side. So alpha x is equal to y minus xy minus alpha xy. So alpha x is equal to y minus x minus alpha x. So y is equal to alpha x divided by 1 minus x minus alpha x. This is something I can make it a bit more simpler. Y is equal to alpha x divided by 1 minus alpha into x, or 1 minus x. So let me rewrite this. I'm going a bit slow, but anyway, we will solve this problem correctly. So minus alpha, that should be equal to 1 plus x. So minus alpha x no, this is not correct. So this equation can be written as, I can rewrite this equation something like y is equal to alpha x divided by 1 minus, I can take x outside, so 1 or alpha minus 1. I think that looks correct. So you have this something as y, so take this y and then plug in this here. So what you will get, some equation like alpha x divided by 1 minus x alpha minus 1, that should be equal to x of by f minus 1 minus f by f into x. So what we have here, so we have alpha, we have x of, we have f, and then from there all we need to calculate is just x, which is something we can calculate. So using this equation you can get the value of x. So for this case x should be equal to 0.412. This is slightly bit complex way, and it's a bit of you need some iterative calculations to perform. Obviously you have to rely on the calculator in the final exam. So maybe I will try to make it a bit simpler, or if not, if there is no data, all I gave is alpha, then you can use this method. That's one way to do it. Or alternatively you can also, no, there is no other method, so you have to stick to this. Or either you can assume a suitable flash temperature to save your time, and then if you have x is equal to 0.412, and then you can also determine y. So all you need to do is, you have x value already here, and then you can get the corresponding y value using this equation. Get a y value approximately equal to 0.632. So this comes, so y should be equal to, alpha is what, 2.45 multiplied by x, which is 0.412, divided by 1 minus 0.412. multiplied by alpha 2.45 minus 1. So this should give 0.632. So once you have this value, you can go back to your txy diagram. So let's say when y is equal to 0.632, so which is around here. So 0.63 is around here. So that's which means and then you draw some line towards your ordinate, then which means the corresponding flash temperature should be equal to 95 degrees centigrade. So this is the bit more complex method, but it's good to learn this method. Yeah. So if I give just the alpha value, try to solve using calculator for different values of x. Okay, so that's the only way you can determine this x value. Anyway, this equation is really easier to solve because you have everything. You have alpha, you have x of, you have f. All you need to calculate is just x, so which is easier to do. So that solves the problem. You can go to the next one.